Good morning, everybody, and welcome to Advent of Code Day 23. It's been a year. It's been nice. Yesterday, I was doing Day 22, and it was Tetris and Jenga in 3D, applying gravity, building a small 3D engine of sorts. Well, that's a bit over-exaggerated, but it was fun. I wrote everything from scratch because I had a 2D library that I made, but not a 3D one, so I made that. And after a lot of debugging, it actually worked, and we had gravity that we could apply and detect whether we could remove some stuff. From hearing other people reason about it, I have not actually looked at other code yet, but I saw somebody else stream that was going to attempt it, and I heard them reason about how they could detect if you could pull one apart. So let me just pick it up like this. My idea was, okay, if I have this block here and there's a block here, just find all the blocks that support it all the way down till the base, right? But what other people did was just look at this block. If you want to remove this one, does this one have a second one supporting it? And if so, this one could be removed if this is true for all the blocks that are above it. That's something that I heard somebody else say, that I was like, oh yeah, I really don't have to do this whole tree down to the bottom, which makes the code run slower as you get higher. But yeah, I still like the way that I did that, but it wasn't the smartest way of doing things. But it left me at part 2. And Amarte was in chat. She was like, I was really curious to see how you respond to part 2. So I said, well, I don't have much time to stream anymore, so I will put off reading part 2 until the next stream. So that is what I'm going to do now. She's in chat. Good morning. She says, how are you today? I'm doing fine. My wife is very sick, sadly. So I've been taking care of the dog and everybody at home. Gave them something to eat and to drink. Took them out for a walk. And then it was like, okay, I have some time to kill. I have like an hour, 90 minutes, something like that. Before I have to go and fix the lunch. So I was like, why not just stream for a little bit, read part 2, maybe read day 23, get the thoughts flowing, maybe get a little bit going, and then do another stream later today or this evening to finish it all up. So yeah, that's where I'm at right now. So let me first just read day 22 part 2, because I'm curious about the twist. And as you can see, I got the star yesterday. We were in chat. Let me just pull it up here. So like after the stream, there were still a few times that I was like, okay, this is not letting go. I want to see what's wrong with my code. So I fixed a few bugs, and then Amarte helped with some outputs, and I just kept going. And we were talking about various stuff. She showed me some very cool, like the. Let me show this. Oh, I need to make it smaller. I should probably pop it out here. Like a visualization of the code in 3D in Unity, which is pretty cool, and just have it all fall down. So that was pretty cool to see. Because this is like when you write this code, this is the first instinct that you get. You want to like make it all visual, but I managed to solve it without making it visual yet. So let's see what part 2 holds in store. Disintegrating bricks one at a time isn't going to be fast enough. While it might sound dangerous, what you really need is a chain reaction. You need to figure out the best brick to disintegrate. For each brick, determine how many other bricks would fall if that brick were disintegrated. Using the same example as above, A would cause all 6 other bricks to fall, F, etc. Disintegrate any other brick. Disintegrating any other brick would cause no other bricks to fall. So in this example, the sum of the number of other bricks that would fall as a result of disintegrating each brick is 7. Okay, so this is just the opposite with a count. This is really easy. I think I can knock this out right now. For each brick, determine how many other bricks would fall if that brick were disintegrated. What is the sum of the number of other bricks that would fall? Okay, well, not exactly, but I have my code that does apply gravity, and I can just simulate pulling out one and then running it. Let me see. Yeah, I think this would just be like for my code here. See all the commented out stuff. Part 2 would be the same thing. First apply gravity, then check if it has no drops. Otherwise just do the full, actually I can just do the full apply gravity, like this one. And then sum the drop there. So if I would just take all of this code and pretend like this is part 2. Remove this one. So we have the gravity applied there. We have all this logic, which is fine. And we actually don't need to do this whole bunch. We just need to do this one. And we don't care about this one either. We can take away all of this code. And we can take this code. We can remove the part 1. Move this up. The implementation has been done. Like this, boom. And in this case, let me see. Around we don't care. The to test we don't care. We don't care about this one. We can strip away all this logic. It won't be the fastest, but it will work. Below unit to test, no, we also don't care. We don't care about this. So now we have this one. Now I removed too much. I need to have, I think it was dropped except the brick. So let me see. Let me see. Brick is dropped. I know we can. Yes, we do. Part 2 test is dropped except new brick. Brick like this. And we do 2 test. Oh no, apply gravity to test. And we do P2 plus equals, okay, drop count. Basically this is it. Good morning, Luke. Oh, I have the wrong video open. Let's see. How fast is your simulation? Not that fast. But I can have the percentage 100 thing in here. So let's do it %10 so that we can see. If I, no, just like this one. Let's do it for every 25 or something. It will be fine. Am I back to being real slow for this again? Yeah, okay, so this isn't the fastest one. But it chugs along. So while this runs, let me read day 23. A long walk. The elves resume water filling operations. Clean water starts flowing over the edge of Island. They offer to help you go over the edge of Island too. Just hold on tight to one end of this impossibly long rope they created, and they'll lower you down a safe distance from the massive waterfall you just created. Let me just pull up this one here. Okay. As you finally reach Snow Island, you see that the water isn't really reaching the ground, it's being absorbed by the air itself. It looks like you finally have a little downtime while the moisture builds up to snow-producing levels. Snow Island is pretty scenic, even without any snow. Why not take a walk? There's a map of nearby hiking trails, your puzzle input, that indicates paths, marked by periods, and forests, marked by hashes and steep slopes. Okay, up, down, left, okay, cool. So this is a pathfinding thing again, and there was one like a few years ago that I couldn't get running fast enough because it got stuck. So I'm really curious to see if this one will be a problem for me. You're currently on the single path tile. in the top row. Your goal is to reach the single path tile in the bottom row. Because of all the mist from the waterfall, the slopes are probably quite icy. If you step onto a slope tile, your next step must be downhill. In the direction the arrow is pointing. To make sure you have the most scenic height possible, never step onto the same tile twice. What is the longest hike you can take? Okay. So this is cool. So this one works, but if there's like this one you can't take. Oh yeah, it can. Let me see. Is there any dead paths here? This is all fine. I don't see any dead paths here. So this will probably be the twist for the path 2, I'm afraid. Maybe like this one takes you to a cloned copy of this in another dimension, and then how do you get to the bottom here while getting back to your original dimension or something? No, but they're all to the right. Wait. These are all just to the right. There is just one downslope, right? I saw one. Yes. Okay. Oh no, there are more. They just... There's no upslope in the current example. That's interesting. Let's see. Non-existent code is the fastest there is. Yeah. We're 2/3 of the way. Okay. So let's also start coding for day 23. And I didn't... this will be a pain, because I can't add a new item now, can I? Will it allow it? Because I need to clone this one. Yeah, it won't allow that, because the code is running, and if I debug detach, I won't get the output, because I haven't written out the output. So I need to wait for a bit. Okay, let me see. Note that. So const graag path marker is this. Forest marker is this. Slope up marker is this. Slope right marker is this. Slope down marker is this. Slope left marker is this. Okay. Was there a starting marker in there? I don't think so, right? No. So this would be 0,1 would be the start point. And we don't care about the endpoint there, okay? Let's see if our answer is correct for day 22. Woohoo! Part 2 in the bag. So yeah, that was a very non-optimal way of doing this, but I had all the code that could solve it in reasonable time, so why not? So the smart thing to do would be to apply all the permutations code that I built here, which I haven't even used, so I've done this for nothing a second time. But I could have used this to just go up and figure it out from that tree that was built. But yeah, we have a simulation. Why not run the simulation a few thousand times? So yeah, cool. Let's store this as the answer in this part of the code. Answer P2. There is no test for P2, so that is fine. Yeah. Let's also just write out the P2 answer to the console. P2. And the issue that I never have this is because I never added to the template that I built. So let's add it to the template that I copy every day as well. So now it's in there by default as well. So okay, I didn't think I would get part 2 so fast today, but yeah, that's a good start. Let's see, 23, 23, and 23. I should maybe also have like a command to add 23 and then do that. Maybe that would be fun to build, like but it would be seriously overkill, but it would be fun to build. Nice, grats. Yeah, thank you. Let's set up this one right here. So these are our markers. The thing is, I think the rules that they set never pose an issue. Like for all those markers, there's always a, like if I take the V1, there's never an impossible path right now. So I wonder why that text is there. So I think that must be for the map is set up in a way that you can't make an illegal move with the rules that you set. So it's really weird to me. But yeah. Oh, maybe you can't enter it from another way. So you can only go like, or you can enter it from another side, but you can't go onto it. I think that's basically the issue there. So yeah, let's take this test map now, set that up as well. We do input.toLines map, and this one will be, let me see, what do I want? I want to know the tree markers, forest markers. I actually don't even care about the periods, because those, everything that's not a forest will be one of those. Then we have the up marker, right marker, down marker, left marker. Okay, so I think that's everything that I want. So that is 2, 4, 5, which is too much for my my extension. So I do as value tuple 3, but I want it as value tuple 5 actually, and I don't have that yet. So let's make it. So this is my destructuring workaround that I really like. Like this, but this one doesn't exist, I think. I already have one for 5. Okay, cool. That solves the issue, because I already went up to 5 for that. So now I can do as value tuple 5. Did I call it 5? Yes. So now what I can do is, this one produces an IEnumerable of hash sat. So we have and I should actually make this return grid locations and not this anymore. And I thought that I fixed that yesterday actually. Map as grid locations. Okay. I fixed that already. I just gave it a new name. I should probably just make this a default though. So this one gives a hashed set of grid location. And then we have the forests, up slopes, right slopes, down slopes, left slopes, like this. And now I can do like this and have it all mapped. Let's make these global here. So now these are all mapped because I do it like this. So we take the input and we convert it into a sparse map, into 5 sparse maps actually. We also need the raw map, by the way. So I need to do a string like this. Raw map is this. Let me just do it like this first. So I do raw map and I use it on that like this. And the reason is because this one will be our bounds. So we set up a grid now. So we do grid is new grid. I thought I had a constructor for that one. don't I? Apparently not. That is fine. So we can do rows is raw map dot length, columns is raw map length like this, and now we have a grid. I actually just want to call this map, by the way, but let me just do that. Okay, so I have everything mapped out, so to speak. So now for part one. This one becomes a BFS again, because we don't want to... actually, we want to make the longest path possible without making... it doesn't matter if it's DFS or BFS, I just need to... Well, it does matter. I will use a priority queue with the inverted, so I can do a simple priority queue. Let's see. I think I've used this one a few times already. But there was also a way for me to determine whether or not it should prioritize smaller or larger values. Let me see. Generic priority queue, simple node I priority, count first. DQ, NQ. I think in the past I've done just a negative value, but I thought there was also a way to indicate whether or not you wanted to have a high-low or low-high. Because there's also this priority queue. And this one is new, right? This one is .NET, and I used simple priority queue in the past, which is just a extended of a library. Let me just see. Oh, we also have our starting point, by the way. Grid location start is, this will be 0,1, because it's like the top left, and I think the ending here is probably the last, the end for part 2. Let me see. Or maybe it's like, what is the unique path you can take with taking all the slopes and still getting to the end or something? For now we just want the longest walk, right? The hike could take 94 steps. The other possible hikes you could have taken were 90. Okay, so this does every one of them. But this one, like at every crossroads, you branch. There aren't that many, like this is the first branch here. Okay. So let me think. We have the queue. We have a hash set of grid location paths visited or just visited. We need to have the length. We need to have the current position. So I can just do like a record walk state like this. So I can do grid location, current, visited, and in length. So now I could make a simple priority queue of walk state. And this one will be int. Like this. Is there any the comparer? No, I could probably use a comparer, but in this case I would just use the negative version of like the negative of the walk length to make sure I get the longest one first, which is fine. And I can do grid, no, in this case map.get walkable neighbors. And then I can do, okay, let me first do q.enqueue. This would be a new walk state. Start new 0, and actually 1. Minus 1, right? So we get the longest first. So this one will take us here. S is a starting marker. Note that. Oh, it didn't tell you how many it replaced. Okay. So I assume the first one doesn't count here. We'll see. The answer for P1 would be 94. So let's start it at 0 then. So while q.count larger than 0. So we have where ws is q.dq. Then we do grid map get walkable neighbors for the current, and this one will be the forbidden list will be forests. Oh, we also have our walk direction actually. Because this one will determine where we can go. So this would be direction, and for the first one, this one will be down. We need to have get. So this one will be a hash set of grid location. Get impossible slopes, and this one will feed in a direction, current direction. And this one will return current direction switch, and then we get direction dot up will return down slopes. Sure. Haha. Direction that down will return up slopes. Throw new argument exception. Invalid direction. Like this. Okay. So this one will also give us the impossible slopes that we want to like this. That one should actually be based on this direction. So this one is interesting. Get possible labels with direction. So this one becomes a grid location direction pair. Like this. So this one would return like this. Okay. And let me also do one that's like a func direction bool. Direction is valid. So now I can do for each var option in get walkable neighbors with direction for current, and then I can do if direction is valid option dot direction yield return option, something like this. And maybe I should also pass in. Yeah, this should be enough. And then I need to have the variations with this one's included, which is a pain. Let me also do that one. Actually, is it easier to just make this one like this? And then we do if direction is not current and not forbidden. So we just extend this logic here. Boom. And then we might want to do this last combination as well. This. And now we have all the combinations that we want. So we want get walkable neighbors with direction, which will then do dir. This would be dir. Contains so like this. I need to also have it pass in the actual value. So this one would be a grid location, comma direction. So this one validates here. So this one would be option dot location like this. Okay. Hey Luke, welcome. So now that we've extended all of that, let's see, is this not valid? Direction, comma bool. I need to have the other overload probably. Let me see. I need to change the signature for this one. Yes. And then we need to have like this. Yes. Okay. Now it's complete. Okay, so this one will var options is this. Then we need to do for each var option in options. Now we need to make sure that we haven't been there yet. So it's not only this one, it's also this one. And my thinking is I should probably have more than one hash set that I can feed in there. Let me see how much work that would be. Because that would mean that I have to swap these around and make this like a params, so that I can feed an infinite amount of them in here. Let me see. Let me first go to this one and make sure that I extend this one. So this one would be then a params, and then would be an array of hash set forbidden like this. And this would means any like this. So that is not too bad. So now I can feed in an arbitrary amount of hash sets to validate, which just means that I will have to change the signature for these to be the other way around, because now this one, a params has to be the last one in your arguments list, because if you're not familiar with it, this just means that you can enter 1 or 100 or none, and it will just work. It's like syntactic sugar around a nice feature, but you can only have one of them, and it always has to be the last one because of the ordering. So I have to make sure that I have any other ones that allow this be, yes. I think I'm already okay here. Error list, the initializer, blah 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 here. So this one needs to be reordered here. And now I can also pass in ws.visited. So now it will make sure that this one are actually valid options that have not been traveled to before. So we can now do q.enqueue new of this. Let me see. Var new visited is ws dot visited dot toArray concat. No, actually I can just do this one. Is new hash set grid location, because I need to clone this. This needs to be its separate version. And then I can do a new visited dot add option dot location. So this one also needs to have start in it already. So this one would be option dot location, option dot direction, and then new visited. And then we do ws.length plus 1, and this will be ws.length plus 1 times minus 1, just to keep it nice and confusing, because we want to get the longest paths possible. Actually, does it even matter? Because we need to take the longest route. There is no end condition here. Let me think. I think actually once the next one... I'll have to think about that. Because this one will take the deepest path always. Oh yeah, I need to do if options that count. I need to do toArray on this one, not toArray. Let me see. If options that count is 0, reached our end. Else, console that right line. Reach the end of the line after steps. Okay, and this one will be options that count, dot length. Let me make sure I do this. If options dot length is larger than p1, console that right line. New longest path found from p1 to options dot length. P1 is options dot length. So this one should walk our entire thing. Let me see. I think this should be fine. Let's see if we can run this for day 23. Okay. Reach the end after 0 steps. Great, because I never enqueue the options. That makes sense. No, I do enqueue the options. That's interesting. That's interesting. Let's see. Boom. Did I wait? If direction valid, okay, sure. So my options here are, I have 1 going down. Valid, nice. We will add this one. So now this one should be 2, yes. And we add, this is not, yeah, this was length, okay. So now we have a queue of 1. Oh wait, what? Why do I both call these options? No, that is correct. Never mind. But I need to do this. dot length. This was the one that I needed. My bad. That was a stupid mistake there, but these are referenced to correct things. Okay, let me just run this again and get some other answers now. 82, 107, 94, 91, 119, 154, 131. Okay, wow. That's interesting. So let's see the path that it takes here. It cannot go down. Wait, it could go down, but that wouldn't result in a longer path? Or what's the issue here? So I should probably print out the path and keep track of the order. Let's do that, that will be fun. So we can do void print path, grid, hash set. Grid location visited, yes, this is all fine. And we also want to draw in the trees and all the other crap. So let me just do it like this, params. And this one will be a pair of locations with a char marker, like this, markers, like this, okay? So we can do for int I is 0, I smaller, let's do row is 0, row smaller than grid.rows, increment row. For int col is 0, col smaller than, yes, we do that as well. Console, right line. Actually, I can just do this. If visited that contains, let's do grid location current is row col, contains current console.write, like this, console.foreground color is color.green, I like green. And for visited we will, let's do the same thing here. Oh, else for each var marker pair in markers, if a marker pair dot location contains current, well, let's only switch here, it's fine. And then I can also do the break, because it should only occur in one of them. Well, not quite, because we might have to overlay the special cases here, but it's fine. Let me just do it like this. Actually, what I can do is not do the else, but just always do this one and then draw over it, so that you will have a broken up map. Which is fine. Console.write marker pair dot marker, like this. This print path, this will be map, this one will be ws visited, this one will be forest marker. Then we will have up slopes, up slope up marker, right slopes right marker, Down slopes, down marker. And then we have left slopes, left marker. Okay. So let's run this, and now we should be able to view the paths it took. Oh. Ah. Never mind. Like this. Let's do a blank space here. Wait, what? How come this one is out of bounds here? That's interesting. Ah, because it will overlap here. Let's make it so. If not has drawn. Like this, okay. Let's mix those. So now I should have the entire thing as I want it. Okay, so you can see this is the first path that it took. And let's just right, this looks fine. This is 82. This one is 107. But it doesn't look like it did 107. Okay. Let me see. Int draw count is 0. Actually, console.writeLine. Visited tiles. Okay, this will be visited.count. So let's see if there's a mismatch there. 83 because this one, sure. It actually has 108. Wait, okay. So why is this one illegal? Let's see if this is... so it takes this one, which is fine. Wait, it never did that one, but it goes here. Oh no, okay. Did it need to go to the end? I didn't, let me see. What is the longest hike you can take? Did they say that it has to end it there? Let me see. Find a beach, snow island, blah blah blah. There's a map hiking. Yes, for example, you're currently at a single path tile in the top row. Your goal is to reach the single path tile in the bottom row. Okay, my bad. My bad. Okay. I didn't account for that. I saw that and I was like, maybe that's a part 2 thing and they just want the longest, but no, it actually needs to be this one. Okay. Okay. We have start and we have end, and let's assign end here. End is map.rows -1, map.columns -2, right? Let me see. If current is end, console.write. Let me validate that I have it correct there. Alright. E console.foreground color red. Good morning, Sunco Software. Nice to see you here. So this will be our visual confirmation that we have the start and endings correctly. Let's make this purple. Purple. There's no purple. Blue. Okay. Start and then continue. Okay. So this is just so that I know that I have them mapped correctly. That is fine. Now I need to make sure that I change this one here to only keep going. So this is no longer a valid option here. And here what I need to do is here we do if option.location is end. This is our end condition. Actually +1 because we haven't gotten there yet. This is also not correct. I need to do this here. Like here, if ws.location.current is end, then I need to do this check. If ws.length larger than this one, actually we don't care because the first time we get here it will be fine. This one will be the answer. We got to the end. Longest path, this one. And now I can do q.clear actually and break. I can just break here, it's fine. So now if I run it, it says 83 is the longest that it could go. Let me see. Which is weird, because that means that there was no other longer path that it could take there. So there is still something off. Because it should have branched here, right? Let me see. Yes, it should have branched here. And this one would have been a longer path. So how is it possible that it didn't do that? because my priority queue is set up in a way that it queues the negative amount here. So it should take the deepest path, the longest path first. Let me see. The longer route I take, the less steps it reports to me. I think my logic has a bug somewhere. Yeah. Let me see. Let's see if the other priority queue does something different. I don't think so, but... So the interesting part would be here, would it actually go down this way? So okay, let me just... if ws.length larger than p1, let's do this. And let's just keep going here. But there is a bug if... so that is one. Here, the 94 one. But how come it will get to this place faster than this one? Because it should take... Oh yeah, no, that's correct. Never mind. Oh, now it has one with 119. Let's see, does it break the rules somewhere? So my question is, if we encounter this, does that mean after this step you also have to take this one? That's the only thing that I'm curious about. Let me read that part again. Let me see, the slopes thing. You're currently on the single path in the top. Let me see. You're currently in the single path tile in the top row. Your goal is to reach the single path in the bottom row. Because of all the mist from the waterfall, the slopes are probably quite icy. If you step onto a slope tile, your next step must be downhill, in the direction the arrow is pointing. To make sure you have the most scenic hike possible, never step onto the same tile twice. Okay, so it only says the next tile. So that means that this would be a valid path, right? Am I crazy? Let's see, it goes here. Then this, yeah, this is fine. But here it was an empty tile, so it doesn't have to continue here, so it can go up. Then here to the right, it continues one, so yes. I don't see an issue with this path. Huh. So the only way that I think this could be an issue is if you're not allowed to go on downwards or upwards from this part, which I think is weird. Like here, do they mean that you can only take this route now? Let me see. So just a question, do they mean that you cannot go down here if you take this route? Is it not allowed to go down here? Do they do that themselves? So to me it doesn't read like that, but it seems like that. So I wonder if I'm just annoyed now. Because they say there's just, it's allowed, but that may not be the longest route. But you saw, there was a longer route than they say. They say the best one is 94. The other possible hikes you could have taken were 90, 86, 82, 82 and 74. I have many more paths that seem to be allowed. So let's see, if we go back up here, right? They say, like, this is the 82 one. Fine, we have that once. Then there is a 94 one. This is the one they want you to take. Then I have one that's 86 tiles. Fine. This also doesn't break that consecutive path thing. No, that's not true because it goes down here. Then this one is 118. And they don't say that this is a valid thing here. So is the example not exhaustive, or... You know what, I'm just gonna run it for the... I think I'm just gonna run it for the real input. Because my answer would be 151 for this thing here. Right? They say this is the example, this is the longest path, but it isn't. Yes, your longer path goes up slip at one point. Okay, so you say there's an issue here. Let me see. This one. Where? I don't see it. It doesn't. Because I've marked all the slopes. It just goes to the right here. Oh, wait. No. Around the center of the map. Okay, let me see. So this one is valid. This one is valid. I'm not sure what you mean. This is allowed. And this one is allowed. But you clear slopes with O's. No, I don't. I don't clear slopes with O's. The second one is not. Why is this not allowed? Because it goes here, it goes on the slope, and the next one is in the right direction. And then it does that. And it even... they do something similar. Where was it? They override it all, but... like this one here, they traverse this one and go to the right, see? So they come down here, down one, then down to the right. They also don't follow in this direction. Oh wait, this one here. You're right. It crosses this one. But that one isn't in my down slopes one. Wait, what? Okay, let me see. Do I have forest marker? Up slopes, right slope, down, left. Yes, this is good. Let me see. The walkable paths. So this is interesting. So this part fails here. Let's see, what would the position be for here? You're right, thanks for catching that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. row 12, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 12,13. Okay, grid location. Marker is 12,13. Let me see. If option equals this, okay, let me see, like this. Okay, let's debug this. This is a good one. Okay, it's not doing anything. Did I break something? What is it doing? It's weird. It's like my code is broken now. Clean? Because I only added this, right? Am I crazy? Okay. Okay. Let's see. So this was a down slope. So down slopes. Down slopes is empty. Okay. Is my down slope marker wrong? Okay, let's see. Up, right, down, left. Up, right, down, left. Oh, wait. Ah, okay. Never mind me. I had this uppercase when it should be lowercase. And now it works. Come on. Okay, so it's always stupid stuff like that. Okay. Print map. This will be if test. Let's not do this every time. There's still the matter that we got to the end before being on the longest path, which is annoying. But that is fine. Let's do false. Let's do this. So this will now try to exhaust all the steps. Okay. 2318. Woo! Gold star in the bag. Yes. Nice. Continue to part 2. Thanks for catching that, by the way, because I didn't see that there wasn't one. And my map, I actually didn't draw over it. I just didn't have the marker, so my map never had it. Yes, okay. As you reach the trailhead, you realize that the ground isn't as slippery as you expected. You'll have no problem climbing up the steep slopes. Now, treat all slopes as if they were normal paths. You still want to make sure you have the most scenic height possible, so continue to ensure that you never step onto the same tile twice. What's the longest hike you can take? Ah, and I already had this, 154. Why is this so easy? This is weird. Okay. This barely changes the problem in my head, but 154 exactly. Okay. I can take away this one. Boom. Let's just do this again. And this time we call P2. Let's not write it out. Actually, this can also be if test like this. Do 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 do. Yes. And now I can just remove this condition, and it should be fine. It's not the fastest code, but it's still weird to me that now you can't do the, like, what would be the inverse of a breadth first search here to make sure that it's actually the longest way to get there? Because others will arrive there with lower numbers, so you can't have the same same condition there, I think. So will I regret this? Will this be a very long run? Probably, looking at this. So I wonder if this is something that I should use like memorization for. Now I'm starting to get curious how many entries are in my queue. 33 only, okay. So am I near the end here? Yes, I think so. Famous last words. Oh no, you won't know that because it's depth first. So everyone that's lower in there could potentially still branch off a major amount of times. I should have probably kept the newest, like this one in here. New longest path, like this. Let's see if we still get some new longest paths here. Actually, have we been to the end yet? I think so. What is my current P2? It's only 18, okay. We're still below the previous number. That's interesting. Okay, so the path that it's taking now is like a wild goose chase that will never actually end up at the spot. So what I'm thinking now, what I should do is actually call the death pass, the dead paths. Sorry. Because if I end up at a how do I call it? Like if I end up here, this one, right? This is a dead path. And what we should do is, for every junction that gets to the end, we should save which ones are correct. And for everyone that didn't get to the end, we might want to at least take the last branch that they took and remove that one. So my idea would be, let's just keep this running in the background, because I will probably have to revisit this after lunch. But there are branching points, right? So let me just, actually I should probably just stop running. Debug, detach all. This one will keep running. Because changes have been applied. Come on, this is annoying. So how big is the queue now? 30. It's shrinking. Okay. It can still run for a very long time. My idea is, what I should do is like hash set grid location branches like this, right? So here we do if options.count larger than 1 branches.add ws.current, right? Like this. So if we have more than one option to take from here, this is a branch point. And we should probably keep track of the last branch point, and also have like this one, like dead branches. Something like this. We should probably try to keep track, like which side of the branch that we took, and make sure that they get recorded, so that we don't take those anymore. And seemingly similar to this, once you end up at the dead branch that has no valid paths, you can just keep culling back. So let me just write a big to-do here. Keep track of all branching points. Then keep track of all the dead branches. And dead branches is actually different. So we would have like a dictionary of grid location, and then this would be the value would be like int total paths, int, and then we do hash set grid location dead paths. So this would be dead branches, like this. So what we would do here is for every possible branch, you can enter it from somewhere, then you have options that you can say, okay, these are dead paths. So once you arrive at that point in your tree, you can check, okay, is this part of partially a dead branch? Okay, out of my options that I have left, are there still valid paths that are not marked dead? If so, take that branch. And then once that one ends up dead, you track back to your last dead path and you mark it as dead. What will happen is, if you keep track of the last branch that you took, once there are no options, you can do the dead marker. So we can do the dead branch marking. else? Right, this one. We need to make sure check if this branch is dead or partially dead. If no non-dead branches options left, mark branch path before this one as dead. And this one, what this one will do, and this is still running, and I'll finish it here I think. Let's say you have a path like this, and it can go here, and you can go here, and here, and there, and there. Let me just write up some stuff, right? Okay, let's say you end here, and this one is a dead path. Then you go here, and let's say this one is like this, okay? Then you go, okay, this one is now a dead path. Once you get to this junction here, you can only take this direction. Once you get here, and this is a dead path, you also mark this one, and now this is no longer a valid path. So then if you get here, you can say, okay, this is now no longer a valid path, so there are just two left. Then you get here, it's a dead path, okay, only one valid option left. This one is dead, so now you can cut off this one. So now the next time you arrive here, you can say, oh, this one is bad, and this way will let you cut off pieces of possible path, shrinking the search space. So in the end, you will end up with just the valid paths and all the ways to get there. So that is basically my idea for how to make this run really fast. Looking at the time, it's not time to take care of the family, make them some lunch, check up on everybody. So I want to take this time and say thank you to everybody for watching and helping. Luc, Amarte, and everybody that watches this on YouTube. Maybe like and subscribe if you haven't already. Leave a comment on the video after if you're watching this not live. It's always nice to see what people think of what I do. So yeah, thank you. Have a good one, and I'll be streaming the rest of this later today or in the evening. So for now, have a good one, and yeah, if I don't see you again, have a nice holiday.